In this video, I will demonstrate a 2D high-speed dynamic area mill. A 2D high-speed dynamic area mill utilizes the entire flute length of their cutting tools to produce the smoothest, most efficient tool motion for high-speed pocketing. The toolpath supports a custom entry method and many others. Microlifts further refine the dynamic milling motion and avoid excessive heat buildup. Custom feeds and speeds optimize and generate safe tool motion. Dynamic area mill machines pockets using one or more chains to drive the toolpath. The outside chain contains the toolpath. All inside chains are considered islands. In this step, you will machine the 6 bigger pockets using the 2D high-speed dynamic area mill toolpath. To select the chains, you will use the chain feature option. From your screen, press Alt-T on your keyboard to remove the toolpath display. Now, select Toolpaths, 2D High-Speed, Dynamic Area. The chaining dialog box will appear. Leave the default settings in the chaining dialog box and pick the following chain as shown. Now, from the chaining dialog box, select the chain feature button. Chain feature allows you to automatically select chains based on the initial chain. Chain feature is most useful when you have a large number of chains in a part with groups of similar shapes and window chaining is not an option. Select the OK button to exit the chaining dialog box. In the Chains option dialog box, enable multiple machining regions to instruct Mastercam to machine all the chains. You can now select the OK button to exit the Chain Options dialog box. Now, in the Toolpath page, select Dynamic Area Mill as shown. From here, select Tool from the Tree View list. Now click on Select Library Tool and choose the Filter button. Select the None button and then under Tool Types, choose the flat end mill icon. Also, under Tool Diameter, pick Equal and input a value of 0.1875. Once complete, select the OK button to exit the Tool List filter. In the Tool Selection dialog box, you should now only see the 3/16 flat end mill. Choose this flat end mill and select the OK button to exit. Your tool will appear as shown. Now, input the following comment as shown. Once complete, from the Tree View list, select the cut parameters. Change the settings for the second toolpath as shown. Change the amount of stock to leave on both the walls and floors to 0. Also, change the percentage of tool diameter to 500. I will now take a brief moment to explain some of the parameters found on this dialog box. Step Over sets the distance between cutting passes in the X and Y axis. Toolpath Radius reduces sharp corner motion between cut passes. Microlift Distance enters the distance the tool lifts off the part on the back moves. Microlifts are slight lifts that help clear chips and maximize excessive tool heating. Back Feed Rate controls the speed of the back feed movement of the tool. Motion Gap Size Retract controls retracts in the toolpath when making a non-cutting move within an area where the tool can be kept down or micro-lifted. Optimize Cut Order defines the cut order Mastercam applies to different cutting passes in the Dynamic Mill toolpath. Once the following changes have been made, select Entry Motion. Entry Motion configures an entry method for the Dynamic Mill toolpath, which determines not only how and where the tool enters the part, but the cutting method or machining strategy used by the toolpath. The previous settings will be saved. All we want to do is change the entry method to profile as shown. Also, enable Output 3D Arc Moves. I will now take a brief moment to explain some of the parameters on this screen. Entry method set to profile creates a boundary based on the shape of the selected chain and uses the tool to ramp into the part. The slot is cleared by taking lighter cuts in the Z-axis until the tool reaches the full depth. Z-clearance adds an extra height used in the ramping motion down from a top profile. It ensures that the tool has fully slowed down from rapid speeds before touching the material. Finally, plunge angle sets the angle of descent for the entry move and determines the pitch. You can now select the linking parameters. Within the linking parameters, change the top of stock value to incremental 0 and the depth to negative 0.25 incremental as shown. Incremental values are relative to other parameters or chain geometry. In this tutorial, the pocket chains were moved to 0.05 along Z-axis below 0. The top of stock and the depth set to incremental is a measure from the Z depths of the chains. If you want to set the top of stock and the depth to absolute, the value should be negative 0.05 and negative 0.3 respectively. Once the parameters have been adjusted, select the OK button to generate the toolpath. Now backplot and verify the part to ensure that the tool motion is correct. Select the backplot icon. Ensure that Tool and Workpiece are enabled and then select the Play Simulation button. Your toolpaths will appear as shown. To view this better, select the isometric view and fit icon. You can now exit backplot. We will now verify the part. Choose the Select All Operations icon from the Operations Manager. You will notice that both operations have now been selected. Choose Verify. Select Isometric View and the Fit icon. Now press the Play Simulation button. Your part will appear as shown. You can now exit Verify.